Okay, so boat moves, it says, at 5 meters per second due north. Okay, so this is the direction it's going in, north, at 5 meters per second. But then the water is moving due west at 2 meters per second. So basically, the water is having that effect on it, isn't it? It's pushing it in the west direction. Okay. So that sometimes can happen, can't it? It pushes it one way, whereas you maybe want to go a certain direction, maybe you want to head north, but it's pushing you west in this case. So part A then, it says find the magnitude of the resultant velocity of the boat. Now what we need to do, we need to think about I and J notation with regards to this, right? So remember the I and J notation. Okay. We've got I represents the positive x-axis, a unit in that direction. J represents a unit vector in the positive y direction. Okay, so in this case, you could see, well, it's definitely going in the north direction. Okay, so the J direction by 5. So that'll be 5J, but it's actually going west, isn't it? So it's going that way to the I direction, so it's going backwards. So basically, its velocity can be thought of as minus 2I plus 5J. Okay, so that's the best way to think about that, right? I and J notation, because that's exactly the setup we needed here. We're given two perpendicular directions, aren't we? We're told it's going 5 in the north, and then the water is pushing it 2 to the west. So why not represent it like that? The fact is then minus 2I to represent 2 units in the west direction, and then 5 to represent 5 units in the north direction. Okay, so to get then the magnitude of this, remember then we need to use Pythagoras' theorem, because you can see here, if you're going 5 one way, 2 the other way, it creates a triangle, doesn't it? Okay, so 5 that way, 2 this way, it creates a triangle in terms of where it ends up. So to get V, we just use Pythagoras. Okay, so remember with Pythagoras, we're just interested in the distances, okay, not the direction. So that side is 2, that side is 5, you square both of them, okay, and then add. Right, so you square that, add them, square root to get your V there. Okay, so that gives us the actual speed. So if you work that out, that comes to be root 29. Okay, so we put that to so many decimal places. So 5.39 meters per second. Okay, part B then, it says find the bearing of the resultant velocity of the boat. Now, for the bearing, we just need to again appreciate what's exactly going on here. And you know what, sometimes it's good to, especially when that's a bearing, to consider the bigger picture in terms of the x and y axes. Fact is, it's going, excuse me, it's going minus 2 in the I direction, 5 in the J direction. So it's going this way, yeah? Okay, so we've got minus 2 here, 5 here. So what I'm going to do now, I'm going to work out this angle theta, okay, which if you think about it is this angle here, yeah, theta there, or you could see it from this diagram here. So there's my opposite of the angle, and there's my adjacent. So tan theta there will equal to the opposite, this side here, which is 5, divided by the adjacent then, which is 2. So theta then will be tan to the minus 1, or 5 over 2. So we get 68.2 degrees. Okay, now it did say the bearing, and remember with bearings, the bearing always measures clockwise from the north. That's how you measure compass bearings. So from the north, we need to have all of that angle there. Okay, for our compass bearing, for our origin there. So we need all of that there. Now you know that is 270 for 3/4 turn. So you're just going to add that 68.2 then on. So the bearing will equal to 270 plus the 68.2. Okay, so you get 338.2 degrees.